And welcome to our YouTube viewers. Congratulations on realizing the channel exists. It is I, Dan, aka Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. Welcome to space. And here is the star around which the Earth orbits. Look at the huge plasma filament here, right in the middle of this active zone. We've seen a minor uptick since yesterday. Radial flux now at 147 solar flux units. Great imagery there from the Solar Dynamics Observatory in ionized helium, 304 angstroms. Check out this huge prominence over here. Flaring has been a little bit underperforming, and most flares, it looks like, are coming from this active region down here. As it approaches the limb, flares become more likely. And we'll be covering coronal holes, coronal mass ejections if there are any, and more. We've got a heightened solar wind too. We'll get to that in a minute. Here's the last 4 hours of Earth's magnetic moment from space. So this is scaled in magnetohydrodynamic pressure, or nanopascals. And we do have a rather high pressure environment here. Solar wind speed over 600 kilometers per second last I checked. We'll get to the details on that momentarily. We had a brief period of geomagnetic unrest. Again, that's the last 4 hours of Earth's magnetic moment from space. Let's put that back to where it was before it refreshed. We don't want the video to be too long. Next, looking at magnetic perturbations here on the ground level. Geospace delta B changes to Earth's B field. This is scaled in nanotesla magnetic flux density. It's Earth's magnetic moment from the ground. And that imagery courtesy of University of Michigan, Geospace Model V 2.0. So we saw a brief period of geomagnetic unrest here late night last night. It all had to do with the angle of the magnetic field. And let's go to that next. It's the real-time solar wind. So basically right in here we had this, you see this red line down here, that negative BZ signal. That has to do with the vertical component of the magnetic field. And that extended period of a significant negative BZ signal is what sent us into geomagnetic unrest conditions. You can see everything mostly remained the same. There was an uptick there in the solar wind speed at the same time. And a negative BZ is more prone to produce powerful currents in the earthly geospace. So we did see the solar wind get all the way up to about 640 kilometers a second there. It's just an ongoing and sputtering high-speed coronal hole wind, and we can expect about 3 days here of additional high-speed coronal hole wind streams. Current conditions are right around 600 kilometers per second for the solar wind speed at the moment, and around 9 protons per cubic centimeter, so it's a nominal solar wind density and a quite high solar wind speed at the moment. Next, we'll move into magnetic data here. Here is the GOES magnetometer situation over the past 3 days, and you can see these spiky readings here. That's typical of incoming high-speed solar plasma. Seeing a little divergence here in the GOES 16 and GOES 17 measurements. And keep in mind, if you're a new viewer, first of all, if you're a new viewer, congratulations on realizing the channel exists. These M's and N's, right? The blue ones are the noon and midnight local time for the GOES 17. It gives you some idea of where those satellites are located in their orbit. Looking at more magnetic data here, here's the heliospheric current sheet. The solar plasma is oriented to one pole or the other, and Earth has just snapped across into a south pole oriented current sheet. So that's the red portion that you see here. There's your south pole current sheet. Earth has just left a north pole current sheet. And let's take a look at the line of sight field plot. That's the top view ecliptic plane field plot. Here's a line of sight field plot. This great imagery shows you the solar B field in blue. And it's a great moment here, right at the end of this. Fantastic imagery there. Right here, It's very interesting because you see the B field is kind of right in the Earth-facing zone there. And that's a result of the north solar polar field migrating to the south and vice versa. That is the solar polar field reversal process at its finest. And here's a look at the coronal hole line of sight plot. We are looking at some south pole oriented coronal holes rotating in here. And again, we can expect about 3 days here of increased solar wind speeds from these north pole oriented coronal holes that are moving to set there in the western limb. So those are sources of high-speed solar plasma. And here is your 193 angstroms view. You can see these fairly well-defined North Pole coronal holes here. The ones over here in the east, those are South Pole, and those will get more defined as they approach Earth, as they rotate into a more earthly-facing direction. Now, next we'll move to sunspots. There's been a minor uptick here in sunspots. Once again, the radial flux now at 147 solar flux units. And we've just got a massive number of sunspots. Again, the most flares have been coming from 3031, right in this southeastern corner of that. And I would also note this oddball sunspot almost exactly on the equator here, sunspot 3034. It looks like it's gained a little complexity there. It could be moving into a more active sunspot, but it's primarily just an alpha class sunspot at the moment. And again, for you new viewers, beta class sunspots with more complex magnetic fields are more likely to produce solar flares. Let's take a look at those in 1700 angstroms. We're going to zoom way in. Make sure you view this next imagery on your large screen TV. 1700 angstroms is just part of the extreme ultraviolet light spectrum, and we can't detect that from Earth. In order to view these wavelengths, they must be viewed from space. These images are from the Solar Dynamics Observatory, known as the SDO. And you can see some flares here coming from sunspot 3031. It's an exciting time to be viewing the closest star. By the way, we streamed for over 12 hours yesterday on Twitch. Thanks to everybody who tuned in over there, twitch.tv/smashomash. Yesterday's space weather video included meteorology and all of our major segments. We did not compartmentalize yesterday. We put everything all together. And if you're not seeing all of our videos in your feed, head to smashomash.com/smashteam and click posts. All of our major videos will appear there. There's no need to log in. But if you'd like to support the channel, become a member at the gold or silver Smash Team level. Thanks to everybody who has. And take a moment to press like and subscribe. Leave us a comment. Let us know if you're new to the channel and how you discovered the content. We think the hashtag system is broken on YouTube, and we're doing our part to make Earth not suck again. One of those things is selling merch, because our merch is largely designed as a conversation starter. It's completely apolitical, by the way. I view things from a pragmatic perspective, and I'm critical of all bureaucrats who make terrible decisions. And so I'm trying to do my part here and make Earth not suck again. By the way, you can save 20% by using the promo code FINDYOURVIBE. That promotion ends today, so save 20% with the promo code FINDYOURVIBE. And tell your friends and foes about this fantastic merch. Make Earth not suck again. There's also a link to our smashomash.org page, which at the moment just redirects you to smashomash.com. It's up to you to make Earth not suck again. If you've noticed Earth's been sucking over the past 2+ years, we certainly have as well. Links to that at the homepage at smashomash.com. Welcome to the Neo-Renaissance. We haven't forgotten about the publication plausibly explaining the mechanism underlying the solar sunspot and solar polar field reversal cycles. So help us out. Visit our links. Thanks to everybody who has. And let's get back to the realm of X-ray flux. So Another important feature is solar flaring. And when we say solar flares, we're talking about photons. Don't get them confused with coronal mass ejections, which are protons. Diffuse gas, completely different. And X-rays are a portion of the electromagnetic spectrum. So we only saw C-class flares here over the past 24 hours. Pretty calm here. And really, these sunspots are underperforming from an X-ray output perspective. Don't be surprised to see major flares. We've got major sunspot groups right in the earthly facing zone. So we are seeing the proton flux here subsiding. Nothing too exciting going on there. And here is the 94 angstroms wavelength. Spectacular imagery there, and you can see some flaring coming from sunspot 3031 especially. And let's continue on here. We'd like to know what's going on above our heads, so here is a star chart. If you're up before dawn, you may see the Moon, Saturn, Jupiter, Mars, Venus, and Mercury all rising ahead of the Sun. I like to use in-the-sky.org. And that is the all-sky chart. If you put in your location, you can create your own star chart. Mine faces the south. That is the direction of the ecliptic. Next, a solar system forecast. By the way, this is not to scale. And I just reiterate, since this is a YouTube video and there's so much nonsense on YouTube, let me reiterate that the planets are not going to kill you. Here's the 1 week forecast for the solar system. As all the planets are on one side of the sun, it is certainly lonely over by Makemake, Haumea, and Ceres. So we've got some limited imagery here on this coronagraph. Let's show the full imagery from yesterday. And as we forecasted, there has been some release of solar plasma. I think yesterday I said something like there's no way that plasma can remain suspended. So let's take a view from Stereo A and Lagrange 1 at the LASCO C3. So you can see down here in the southwest, there is this huge plasma plume, and you can see that just kind of slowly diffusing out of the corona. So there's yet another forecast about coronal mass ejections. And as we forecasted also, it's not earthly directed. You can see here on the SOHO LASCO C3, it's all off to the bottom right because it is going to miss Earth. It's also just low-speed diffuse plasma. It's not a particularly exciting coronal mass ejection. But there you have that. I'll bring that back to show you the meaty part of it. Since then, it's been pretty inactive. Remember, folks, we don't need to see sunspots or solar flares to see coronal mass ejections. Coronal mass ejections are protons. Solar flares are X-ray photons. We'll close out today's daily space weather with the 131 angstroms view. It, along with 94 angstroms from the SDO, are the two best wavelengths to view solar flares. They're specifically designed for that purpose. And our channel is specifically designed largely to cover things like science and space weather and so on. So thanks again for tuning in, everybody. We appreciate your patronage here at the Smash News Network, least busted name in news, and may that solar wind be at your back.